All right, ladies and gentlemen, today we are going to go into writing equations of the hyperbolas. As you guys are aware, right now the two formulas that we have the x squared, uh, excuse me, over a squared minus y squared over b squared is 1, and the other one was y squared over a squared minus x squared over b squared is 1. Now, remember, it depends on which one they're going to be, depending upon if the x comes first, it means it's going left and right. If the y comes first, it means it's going up and down. Now, you can always double check that in the calculators, and I was finding out that when we do use the, if you use the stuff online, unfortunately, that Chrome extension I gave you guys doesn't have the hyperbola, the conic stuff in there. I'm not quite sure how you can program that into the actual extension. So what I'm going to do is I'm going to push out to you guys later on the formula sheet, so you'll be able to reference it whenever you need to. Okay. So just again, you'll notice that in this picture, if you look just sideways, the resolution a little bit there. When x squared comes first, it goes left and right. When y squared comes first, it goes up and down. Now, remember, the a value is always the distance from the vertex to your, excuse me, center. I should write this out again. Sorry, it's your center to vertex. Excuse me, center to vertex. Your b value is your center to what we call the covertex, even though there isn't technically a covertex in a hyperbola, but we just call it that way because it keeps it consistent. The c value, again, is always center to your focus. Now, as we go through these things, what we're going to wind up doing is there's going to be a couple different examples for writing out the equations. Now, obviously, the easiest thing to be able to do is we're always going to be able to try to draw it to get the idea of where your center is going to be located, but today, our center is going to be located at 0, 0. I'm not going to move stuff around on us yet. We'll do that, probably start doing some of that stuff tomorrow. So, let's take a look at an example. I'm going to use the wording that CUDA uses right off the bat. CUDA calls the endpoint of the conjugate axis that stands for your covertex. Okay, so get a rough sketch of the idea of what this is going to look like, so we know which direction it's going. Vertex at 0, 4, 0, negative 4. So our vertices are up and down. That tells me that it's doing this. If my vertices are up and down, that means these have to be on those parts. So we know that's going to be a y squared first. Excuse me. Hyperbola. The vertices are at 7, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And now we know, since our center is at the origin, also your center will always be located at the midpoint of here and here. So if you add that distance up, you're going to get, and take half of it, you're going to get 0. So let's see. This is our a value. So our a value is 4, which means a squared is 16. Our b value is the distance from center to that covertex. So your b value is 7, which means your b squared is 49. In this one, we did not need to worry about anything for the c value. So your final result here would just be y squared over 16 minus x squared over 49 is 1. Okay? Another version of this that we can do is when you're dealing with the perimeter of that central rectangle. Now remember, the central rectangle, I'll go back to another example here. If I was to finish and have to draw this one completely out, my rectangle would have been drawn all the way through here. That way you knew where your asymptotes and stuff would go as well. Okay. Now, remember, perimeter is distance around. Well, this one would have a perimeter of, well, if this is 7 and this is 7, this whole length was 14. If this was 4 and this was 4, this whole length would have been 8. So you'd have 14 plus 8 and double it. Okay. So that would have been what? 22. So your perimeter would have been 44. That's how that would work. So if I give you the perimeter, could you work yourself to figure out the other parts that we need? Again, let's start by rough sketching. we rough sketch. We know our vertices are at 0, 10, 0, negative 10. So if my vertices are up and down, that tells me that it has to, again, be a y squared hyperbola. That just means the y value comes first. Okay? So the perimeter of this central rectangle that we use to get all the way around this, well, it's a rectangle, which means that opposite sides are congruent. Well, if this much is 10 and this much is 10, that means each of these two sides are 20. This horizontal distance and this horizontal distance has to be the same. So we take our 68, back out our two sides that we know, and we get 28. Which therefore means then I divide that in half and I get 14. So each one of these distances is 14, which means this has to be at 7, 0, and this is negative 7, 0. Okay, to give you your overall distance. So there, you know now that your B value is 7. So our A value was 10, so we get y squared. 10 squared is 100, and 7 squared is 49. Okay. And then lastly, kind of alluded to this, if I know the equations of my asymptotes, I therefore would know what my slope was, which means I would know what this endpoint piece here would be, which would allow me to figure out what this spot is. Let me show you what I mean. For example, if I have vertices located at 0, 6 and 0, negative 6, and I honestly didn't mean to make all of these up at y equals, I guess it just kind of happened, or the y squared parabolas, or hyperbolas, excuse me. 0 and 6 go up 6 and down 6. So it's got to be a y squared. Vertices, that means your A value is 6, so we know that A squared has to be 36. Now we're going to figure out this B value. Well, we know that in this case here, our slopes of our rectangle that go through here and here are at negative 3 and positive 3, which means I had to go up 3 over 1. If I go up 3, over 1, I'd wind up here because as I'm counting upward, up and over, once I get to touching this top rectangle piece, that distance was 6, I know that I can't go any more over. So that means this has to be at 2, which means this value here is 2. If I go the other way, if I go down 3, 1, 2, 3, over 1. Down 3, 1, 2, 3, over 1. I can't, well, as soon as I hit this imaginary rectangular box, because you know, the vertex creates parts of that rectangular box. Once your slope hits that part of the box, you have to be able to stop there. So that tells me that my B value is 2. So, if you square 2, hopefully you can do that, you get 4. All right. Once again, I got a couple of these things on the formative stuff for you guys. Keep up the good work. Remember, this is all do no harm. And we'll talk about some shifting stuff tomorrow. Take it easy. We'll see you guys later.